we're going to look at an application of exponential functions, which is compound interest. And it looks like my pens aren't working. Oh, there we go. Beautiful. Now, do you know what compound interest is and how it works? So the basic idea of compound interest is you put in a certain amount of money. So they're saying you're going to put in $100 into a savings account that pays 2% annual interest compounded annually. The compounding period is how often they pay you interest. So if they pay you the interest only once a year, that means at the end of the first year, 2% of 100 is $2, and you would have $102. But then at the end of the second year, now you not only make 2% on your initial $100 again, but you will also make 2% on that $2. And 2% of $2 is a nice, how much is that? 4 cents. So at the end of 2 years, the 1.02 that you're multiplying by actually happens twice. And if you would do 100, if I multiply that out on my calculator here, yes, you get another $2 for your $100 and an extra 4 cents. Simple interest would mean that they just pay you the same interest all the time. But compound interest means you start making money off of the money you've already made. So you make interest off of your original amount plus the interest from the last time. So the more often it's compounded, the more money you would make. For example, in this one, it's compounded annually. If they would compound it semi-annually or twice a year, that means after 6 months, you would be able to get half of what you should get in a year. So 2% in a year would have been $2. After 6 months, they would give you $1. And you would have $101. And then after 6 months again, they would say, well, now that you have $101, 2% of $101 is $2.02. So 2% of $101 is $2.02. And since you just have 6 months, you'd be entitled to half of that. And so you would get $1.01. And so if it was compounded every 6 months, at the end of 1 year, you would have $102.01. If it was compounded every year, it's $102. So the fact that you have compounded it more often means you would have made 1 more cent. Not a lot. And if you go to Dollarama, that doesn't matter anyways, because they just round it down. But the more times it compounds, the more money you would make. Now, there's a formula for compound interest, and sometimes it's written this way. Sometimes I've seen different letters used. So that's the same formula. And it's important to know what each of the things stand for. So principal, that's why sometimes it's the letter P, is the original amount. The interest rate, sometimes it's R, sometimes it's I. I for interest, R for rate, depending on which textbook you're using. And then N stands for the number of compounding periods per year. So in our first example, when it was compounded annually, then n would be 1. If it was compounded semi-annually, then n would be 2, because you're paid twice a year. If it's compounded monthly, then it would happen 12 times in a year. So the value of n changes, and then t is time in years. So the number of compounding periods, that variable n shows up twice in this equation. Now that formula is no longer on your formula sheet. They took that formula off your formula sheet, which initially makes you think, does that mean I have to memorize it? No. For all the formulas that they use in this unit, they will give you the formula on the exam, and then with what everything stands for. The reason they took it off of the formula sheet is they wanted to be able to ask you any formula. So instead of having a formula sheet with way too many formulas, you just have to be able to work with formulas with whatever one they give you and understand what each of the things stand for. So that's the reason why it's no longer on your formula sheet. So let's look at this first example. A principal of 1,500. So in this case, let's say they gave you the formula in this form. If they gave you the formula in this form, they would tell you what each of the things stood for. So you would say A is the amount after T years, P is the principal, R is the interest rate, and they would put in brackets that it's the interest rate as a decimal, not a percentage. N is number of compound periods. Per year. And T is time in years. So you would get this extra part on a test or an exam. They would tell you what each of the things stands for. Okay? So with that in mind, principal 1,500 invested 4%, compounded quarterly. Quarterly means 4 times per year. To the nearest quarter of the year, when will the amount be 2,500? So when we put things into this equation, we know the principal is 1,500, the interest rate 4%, so change that as a decimal point, 0.04, compounded quarterly 4 times per year. So n is 4, and you want it to be 2,500. So the amount after T years would be 2,500. So now we have to solve for t in the exponent. So far, the only way that we've been able to solve this without our calculator is if we can get the bases the same. However, if I do a little bit of simplifying here, I'm going to divide both sides by the 1,500. I'm going to simplify this. This will be 0.01 plus 1. Okay. So first of all, on the right-hand side, I want you to see that the base is 1.01. Was that in our powers chart anywhere? No. Okay? This side, I could simplify this side. The 0 is 25 over 15. So those numbers are not on our powers chart. So at this point, this can't be done without a calculator. So we're going to need a calculator. Now on your final exam, you're not allowed a graphing calculator. And for what we know right now, based on what I've taught you so far, the only way you could solve this is with a graphing calculator, where you put this into y1 and this into y2. I'm going to show you what that looks like. So I go to my calculator. y1, I put 5/3, 1.01, 4. There's no t, so you just use x. We graph it. Doesn't quite look like it intersects on my window, so I might have to go to my window. Change my x max to 20. Now the two graphs intersect. So I can calculate, second, calculate the intersection, push enter 3 times, 12.8 years. I guess if this was an exam, they would want you to put 3 decimal places. 12.834. I'll read the question again just to make sure they didn't say round to the nearest something. To the nearest quarter of a year. How do you round 12.83 to the nearest quarter? What are quarters? 0.25, 0.5, 0.75, or 0? Is 0.83 closer to 0 or closer to 0.75? years. Now, because you don't have a graphing calculator on your final exam, we're going to learn how to do this same question. Okay, 12.83. You're going to, excuse me. I'm just going to that's also 12.83. If you look at what I typed in, it should make 0 to no sense whatsoever. I typed in the word log into a bunch of things, and I happen to get the same answer. So this is what we're leading towards. We're going to learn how to use the log button, okay? Because the log button is an inverse of exponential functions. So all the way along for math, you've learned how to undo things. Like adding, how do you undo adding? Subtracting. That's like the very basic things. What's the opposite of dividing? Multiplying. So those are the first things. Then you got into squaring. How do you get rid of something squared? What's the opposite? Square root. That was the first time you probably had a symbol that was really different. Right? X squared and the square root are weird looking symbols when you first learned them. You're probably pretty used to them by now. The inverse of exponential functions is the log function. And so it's going to look really weird at the beginning, and we're going to learn how to use it. But for now, for this question at this part, They just expected you to be able to use a graphing calculator to solve it. So I'm going to give you questions to practice, but we're not going to do them right now. You might even want to leave these questions until later, since you know you can't use a graphing calculator on the exam. Maybe you want to leave them till later to see if you could do them without a graphing calculator or without the graphing part of the graphing calculator.